what's up? Today we're going to talk about bioavailability. So what's bioavailability? Before going ahead, let's make it clear with figure. Suppose this is a man. Now this is his trachea, right? And this happens to be his bronchus, and this is his alveoli, and this happens to be his lung. Now when he inhales some drug, D, now the drug has to come all the way down here, and it has to come into the alveoli, and it has to diffuse from the alveoli into the blood vessel, and the blood vessels finally lead into the systemic circulation, right? So, suppose the drug administered was 800 milligram. Now, only suppose 400 milligram of drug got into the systemic circulation. Now the question is, where did that 400 milligram of drug go? The question is that. Because only 400 milligram of the drug is in the plasma or systemic circulation. So the concept is bioavailability is the fraction of the drug that makes into the plasma or that makes into the systemic circulation. So the question is, where did that 400 milligram go? As I already asked before. And the answer is, we're going to get into the next topic, that's first pass metabolism. Right? So for now, just we need to understand is all the drug we take that does not make into the systemic circulation unless it is the IV route of administration. Okay, so to define bioavailability, it is denoted by F. Is the fraction of drug, that we administer, which goes into the systemic circulation. So since it's fraction, it's denoted by the letter F, right? So now there is a way to determine the bioavailability of a drug. Let's talk about the experimental method, right? And one thing. So now let's calculate this. So if only 400 milligrams of the drug went into the systemic circulation out of 800 milligrams we administered, then it comes to be 0.5. So bioavailability of the drug that we administered in the patient was 0.5. So just because we feel easy to eliminate this decimal to make it easy, we can express this in percentage also. So bioavailability can be expressed in 0.5 in decimal or in percentage, right? Now, just before I told, we can calculate the bioavailability experimentally. So let's make a graph. Suppose this is your x-axis and this is your y-axis. Let's give it a name. This is time axis, and this is plasma concentration. Plasma concentration, right? Suppose we administer a drug in a patient, an extra vascular route. By extravascular route, we administer the drug. Now, the drug appears in the plasma. It makes a graph like that. It reaches a peak, and from there, it's all the way downhill. Right? Now, we administered, after some time, we administered the same amount of drug in a patient, but by a IV route. So it's clear to you by now. So whenever you administer a drug in a patient by IV, it doesn't involve any absorption process. So there is no any loss of drug. So if you administer 800 milligram of drug IV, there's no loss of drug. So it starts right from 800 mg. Now it disintegrates and it gets eliminated and finally it becomes 0 in the plasma. But when you administer drug by oral route or by inhalation or by intramuscular route, then it follows this graph. So this is extravascular curve, and this is intravascular route of administration curve, right? So as I told before, when you administer a drug IV, there is no any absorption process involved. So there is no loss of drug. How much amount of drug you administer in a patient, all the amount of drug goes into the blood. So suppose if it was 800 mg of the drug we administered, then this is the 100% of the drug that went into the blood, right? So this is what we consider all the amount of drug that went into the plasma of the patient. So this is 100% of the drug, right? Now, if we administer the patient by other route except the other than the IV route, then the graph happens to be like this. Let's use another color here. The graph comes to be like this, right? How do we form this graph? For example, now this is extravascular, this is intravascular. So for now, let's only see the extravascular curve. At time 1, the concentration is 0. At 0, the concentration is, let's say, at time 1, the concentration was this much. At time this, the concentration was this. At time this, the concentration was this. And at the time this, the concentration was again this. At time this, the concentration was again this. So the graph is formed like this. You know how to basically plot the graph, right? So the graph is plotted like that. And again, in the same patient, we give the drug IV, and again we plot different plasma concentration at different time. Now we get this graph. Now we assume that when you give a patient IV drug, and all the amount of a drug is present in the plasma, there is no absorption process involved in there. So we get all the drugs in there. So total amount of the drug was this much. What would be the amount? The total amount of the drug administered in the patient was this, which is all present in the blood. Now, in the same patient, we give same amount of the drug, but not by the IV, by oral route. When we give same patient oral route, by the oral route, the same drug, then the graph comes to be like this. So this is the total amount of drug that could have been present in the plasma if it were given by an IV. Or this is the total amount of drug that was administered. Now, this graph represents the total amount, the area under the graph represents the total amount of the drug that is present in the blood when given by an extravascular route. So out of all this drug, out of all the drug given, how much of the drug is present in the plasma? So if we divide the area under this curve, extravascular, by area under the curve under IV administration, we get a fraction. And the fraction represents the bioavailability, right? So suppose the area of this curve comes to be 800, suppose, suppose 8, right? And the area under this curve comes to be 4. Now, the bioavailability of the drug becomes 0.5. In a percentage, we can express in 50%. So this is how we can determine the bioavailability of the drug by experimental method. So basically, the gist of this video is bioavailability is nothing but the fraction of the drug that goes into the blood or that's present in the plasma. All the amount of drug we administer cannot go into the blood, only its IV route. So the fraction of the drug that makes it into the plasma or the systemic circulation, that's the bioavailability. And it's expressed in fraction, what percentage were in decimal, and it is represented by the letter F. And we can find out the bioavailability of the drug by experimental method, which I've shown here. So this one's for today. See you in the next video. Thank you.